This problem is fourth problem of last IMO 2022 IMO International Mathematical Olympiad. It is first problem of second day. We want to see how we can approach a problem like this. Here we should prove, for example, cycle. We want to prove 4 points lie on a circle. It means cyclic quadrilateral. I want to tell you the four important rules, four important ideas in or approaches in cyclic quadrilaterals. Okay, let's jump into the problem. It says let ABCDE be a convex pentagon. ABCDE such that BC equal to DE. BC equal to DE. Okay. Assume that there is a point T inside ABCDE here with TB equal to TD, TB equal to TD, and TC equal to T. 1, 2, 3, 1, 2, 3. Okay. And ABT equal to TA. ABT is this angle I showed with the point equal to TA. I show with the point. Okay. Let line AB intersect lines CD. It is AB, line CD at P, and CT at Q. Okay, so CT is what? CT is this at Q. Respectively, assume that the points PBAQ, PBAQ occur underlined in that order. Let line AE intersect lines CD, and so let's see. AE intersect line CD. AE CD at R. Okay, and DT at S. Okay, R and S respectively. Assume that the points REAS occur underlined in that order. REAS. Okay, REAS. We will see. Okay, the order is this. Prove that the points PSQR lie on a circle. PSQR. Okay, let's prove this. The figure is this, and you want to prove why PSQR is cyclic. So I will tell you four important and basic rules when you want to prove a quadrilateral is cyclic. So two of them related to angles and two of them related to lengths. So these two. Next one, again, we should draw quadrilateral and the diagonals. The last one, we should draw an equilateral and extensions of the opposite sides. So let's see. It is first one, it is second one, it is third one, it is fourth one. You should memorize them. It is ABCD. The first rule is ABCD is cyclic. If and only if angle A plus angle C is 180, sum of opposite angles equal to 180. Here, we consider A1, B1, they see the same side. So ABCD is cyclic. If and only if angle A1 and angle B1 that which see the same sides equal to each other. The next one related to lengths. The intersection of diagonals is P. So ABCD here is cyclic. If and only if AP times PC equal to BP times PD. Look, the proofs in all of them at first, let me tell you strategy of proof because it is useful in many other problems. Consider ABCD is cyclic, then you can easily prove the rule. For example, here by similar triangles, here they see the same arc. Here A plus C will be sum of arcs of triangle, a circle over 2. And after that, from this part, for example, you want to consider A plus C 180 and want to prove ABCD cyclic, try to use contradiction, okay? And use the previous one for ABCD cyclic A plus C 180. And then you say, okay, for example, sum of two opposite angles equal to 180. If the quadrilateral is not cyclic, you draw a circle passes through 3 vertices, and then you can reach contradiction. If you want to know the contradiction, how we can reach contradiction strategies or what, as I said before, feel free to send a message to my WhatsApp number in the description and comments. Then the last rule is ABCD cyclically. If and only if PA times PD equal to PB times PC. Okay, so we have these rules. Now, let's analyze this problem. These two triangles, we work a little on assumption, a little on the sentence of the problem. So, first, we will see, okay, these two triangles are congruent by what? By three sides. Because TB equal to TD, then TC equal to TE by assumption of the problem, and BC equal to DE. So by which criteria? Three sides. We can say triangle BTC is congruent to triangle TDE. Okay, so these two triangles are equal, so we can say the angles are equal. Let me write the angles. For example, you can say, here I've considered these two angles from assumption of the problem that are equal alpha alpha. We can consider, for example, it is 1 point, it is 2 points, let's consider 3 points. See this side, 3 points, and 2 points. See this one, 2 points. Okay. Now we try to see how can we apply the, for example, angles are equal or anything like that. Here, we can say what? We can say this is alpha, this is alpha. And if we consider this triangle, and let me draw with lines. So let's consider this triangle, okay, the pink triangle and the green triangle. Both of them have alpha. Okay, now if we consider one of them, pink triangle has this angle, green triangle has this angle. This part is in common, okay, in both of them. And also we can say something. We have T1 point. This angle is 180 because it is a straight angle. It's 180 minus 1 point, T1 point. And this angle also is 180 minus T1 point. So if, for example, we consider it is T1, it is T1. This one is 180 minus T1 because of here. This one also because of here is 180 minus T1. So we have also another angle that are equal in these two triangles. Let me draw like this. Draw like this. Okay. So we can say by two angles, which two triangles are similar? Pink triangle, QBT, and the other one, ST. So these two triangles are similar, so we can conclude that angle S1, if I consider S1 equal to angle Q1, okay? And also, what can we say about the ratios? We can say ST alpha sees that, in this part alpha sees QT, ST over QT. Equal to, in many problems, also AMC problems, BMO problem, British Mathematical Olympiad, USAMO. You should try to find similar congruent triangles, so much important, so much helpful, also AMC. So from basic round up to also IMO. Finding similar triangles, congruent triangles can be so much useful because after that we can find cyclic quadrilaterals. Okay, so here, ST over QT, we can consider TE. S1 sees TE, Q1 sees what? TB. Okay? And also you can write the other side. But let's consider from this part. If we cross multiply ST times TB equal to QT times TE. Okay. ST, let's consider something. Here I say, okay, we call this length A. This length will be A, this length B, this length B. So ST times TB. TB is what is A. So ST times A equal to QT times TE. T is what? B. But as you can see, we have two B's, okay? So instead of this be TE, we can replace it with TC. And we said, okay, TB is A. Instead of that, also you can write TD. So we can conclude ST times TD equal to QT times B. QT, this B, CT. Now, one important rule we found. ST times TD, ST times TD equal to QT times TC. It is related to one rule of cyclic quadrilateral here. AP times PC equal to BP times PD. So this quadrilateral is cyclic. Now, can you tell me here, because this product ST times TD equal to QT times TC, which quadrilateral is cyclic? SQDC. Okay, so let's erase. Oh, let's do Control Z. Okay. Now we can conclude. SQDC is cyclic. Okay, and you don't need to write the proof that why, for example, if the product equal, because it's so much basic, they accept that for conditions for proving cyclic quadrilateral. Now, I want to prove SQRP cyclic, but we found that SQDC cyclic. Now I want to do something. I want to use second rule here, that if two angles see the same sides and are equal, then that quadrilateral is cyclic. So I want to prove what? Because I want to prove SQRP cyclic, I want to prove this angle equal to this angle. So let's write this angle as x, this angle as y. I want to prove yx equal to y. But so the problem is equivalent that yx equal to y. Because SQDC cyclic, so this angle equal to this angle, okay? So we can say, for example, let's consider this angle W. X plus W here, see same sides as this, so it will be X plus W also, okay, this angle. Because both of them CQR, because SQDC cyclic. And what else can we say? We proved that S1 equal to Q1 here. So this angle is also W. Now, this angle is exterior angle of these two angles. Okay, so X plus W in which triangle? In triangle QPC. Exterior angle, external angle is X plus W equal to sum of two non-adjacent angles of the triangle. It's W plus Y. So from this part, we conclude that X equal to that Y. And here, by second rule, we've proved that this, because X equal to Y, SQRP is cyclic. Okay? So we proved this problem only by applying similar triangles, congruent triangles, and cyclic quadrilateral. But in some other problems, we need, for example, some rules in angle bisectors, or medians, or altitudes, or perpendicular bisectors. Each of these lines has a lot of rules, and if you learn them in any problem, that can be useful. If you want to learn, and I can say 40-50 important ideas and rules and formulas that you should memorize, learn. If you want to learn them, as I said before, feel free to send message to my WhatsApp number in the description and comments. Thanks for watching this video. Have a great day and bye.